Good morning to all. Today's class about probability and queuing theory, Unit 1, Random Variable. What is a random variable? The outcomes of many random experiments may be a non-numerical. It is inconvenient to deal with this descriptive outcomes mathematically. For example, when you toss a coin, we get two outcomes, namely head or tail. We can assign numerical values, say 1 to head and 0 to tail. This interpretation is easy and attractive from mathematical point of view and also practically meaningful. For example, the students sat for an examination and X denotes the number of students who passed. Describe the random variable X. So there are the condition is given. There are three students. There are S1, S2, S3. So there are three students sat for the examinations. So there are possibilities are the first bench, the none of students can sit. This in the next is the first student, and then third is the second student, and then fourth, third student, first, second, third. Next they can sit first and second sit together. Next, second and third students can sit together. Third and first student can sit together. And the last possibility is first three students are sitting together. And here the number of students who passed X. So the first, the none of the students, so the probability, the passed condition is the number of student is, it is 0. And next S1 is 1 because only one student. S2 also only one student. So the number of students who passed it is 1. S3 is 1. And S1, S2, so the number of students are 2. It is 2. S3, S2. So the number of students are 2. It is here 2. S3, S1 also 2. And S1, S3 also 3. Now, probability. So we have the probability. First of all, probability formula P of A is equal to N of A by N of S. N of S is the total possibility of outcomes. So there are three students. So number of possibilities are here. 1, 2, 3, 4, 5, 6, 7, 8. So this is the total number of possible outcomes. Next, first X is equal to 0. If X is equal to 0, what is the possibility? It is 1. So 1 by total number of N of A by N of S. N of A is equal to, it is here 1 by 8. Next, for X is equal to 1. So the number of possible outcomes are, and X is equal to 1 is 1, 2, 3. So X is equal to 2, 1, 2, 3. So here 3 divided by 8, because if there are one outcomes N of A, so there are three possibilities. So 3 divided by N of S is equal to total number of outcomes is equal to 8. So it is 3 by 8. If P of X is equal to 2, X is equal to 2, how many possibilities are there? 1, 2, 3. So there are three possibilities are there for X is equal to 2. So 3 divided by N of S. N of A is equal to 3, N of S is equal to 8. So 3 by 8. If X is equal to 3, 1, 2, 3. So there are possible outcomes are N of A is equal to 1, because 3 is only one possibility is divided by total number of possibilities are 8. So 1 by 8. So this is the basics of the random variable. Next, we can see what are the types of random variable. Here, the random variable, namely there are two types. It is discrete random variable and another one is the continuous random variable. First is the discrete random variable. A random variable X is discrete if it assumes only finite number or countable infinite number of values. It is called the basics definition of the discrete random variable. For example, the marks obtained by a student's in an examination, it is possible values are 0, next 85 or 100. It is the countable number of finite number of countable. Okay, folks, it's a countably finite number of outcomes, and also finite number also we can say. So this is called the, because 0 not only for 100, 1000, 10,000, even for lakhs also we can able to count. The number of students who are absent for a particular period, for example the first period, we can able to say there are 5 students are absent, 10 students are absent, 10, 100. So it is the countable number of outcomes. So this is called the discrete examples of the discrete random variable. So in this discrete random variable we can have, there are 4 formulas. First is the probability mass function PMF. The formula is summation of I equal to I equal to 1 to infinity, sigma I equal to 1 to infinity, P of xi is equal to 1. Next is the mean. Mean is equal to E of x is equal to sigma I equal to 1 to infinity x into P of x. We can say sigma into x into P of x, or in general we can say sigma I equal to 1 to infinity xi into P of xi. And E of x square, sigma I equal to 1 to infinity xi square into P of x. General formula, generally without I also we can able to say x square into summation of x square into P of x. Next is the variance. Variance formula is E of x square minus E of x the whole square. And last is the cumulative distributive function formula CDF, which is capital F of x is equal to P of x less than or equal to x. Capital X is the cumulative distributive function CDF, capital F of x. So here the formula is P of capital X less than or equal to small x, which is equal to sigma I equal to 1 to x into P of xi. So this is the formula for the cumulative distributive function, that is CDF. And next is the continuous random variable. We can start the problem. So before we start the problem, I will tell you the formula for the continuous. Next is some basics properties of the expectations. Now if x and y are the random variable of a comma b, or the constants, then E of A is equal to A. For example, E of 2 is equal to 2, E of 10 is equal to 10, etc. E of AX is equal to A into E of X. E is the expectation. For example, E of 2X is equal to 2 into E of X. E of 10X is equal to 10 into E of X. This is the second formula. And the third formula, E of AX plus B is equal to A into E of X plus B. For example, E of some 2A plus some 2X plus 4. So 2x plus 4, what is the answer? 2 into E of x plus E of 4. E of 4 equal to 0. So the answer is 2 into E of x. E of A is equal to A. Therefore, E of 2x plus 4 is equal to 2 into E of x plus 4. Next, E of x minus x bar is equals to 0. Next, modulus of E of x less than or equal to E of modulus of x. E of x greater than or equal to 0. If x greater than or equal to 0 means expectation always greater than or equal to 0. E of x plus y is equal to E of x plus E of y. E of xy is equal to E of x into E of y. E of a into g of x is equal to A into E of g of x. E of gx plus a is equal to E of g of x plus a. Next, E of modulus of g of x, which is equals to g of E of x. E of g of x is equal to g of E of x. P of x greater than or equal to a, which is less than or equal to E of x by a, comma a greater than 0, which is the Markov inequality, and is the Chebyshev inequality. P of x minus E of x, which is greater than or equal to k, which is greater than or equal to sigma square divided by epsilon square. This is the Chebyshev inequality. And next is the some properties of the variance. Variance of x greater than or equal to 0. E of x square greater than or equal to E of x the whole square. Variance of b equal to 0, where b is the constant. If x and is a random variable and a is the constant, then variance of ax is equal to a square into variance of x. If a and b are constants, then variance of ax plus b is equal to a square into variance of x. If x and y are two independent random variable and a comma b are the constants, then the another formula for the variance a, variance of ax plus by is equal to a square into variance of x plus b square into variance of y. So these are the formulas and the properties of the variance, and these are the properties of the expectation. And the last formula, cumulative distributive function. If f is the distributive function of a random variable x, then p of a less than x less than or equal to b, which is equal to f of b minus f of a. If f is the distributive function of a random variable x, then 0 less than or equal to capital F of x less than or equal to 1. And f of x less than or equal to f of y if x less than y. In other words, all distributive functions are monotonically non-decreasing and lie between 0 and 1. And the third formula for the cumulative distributive function is f of minus infinity, which is equal to limit of f of x is equal to 0 and f of infinity is equal to limit of x to infinity f of x is equal to 1. So formula for the cumulative distributive function, which means CDF. And in the next formula, p of a less than x less than or equal to b, which is equal to f of b minus f of a. P of a less than or equal to x less than or equal to b is equal to p of x is equal to a plus f of b minus f of a. P of a less than x less than b, which is equal to f of b minus f of a minus of p of x is equal to b. P of a less than or equal to x less than b equal to p of a less than x less than b plus p of x is equal to a. And in general formula, suppose capital F of x will be given, we have to find the probability density function of small f of x, which is equal to d by dx of the capital F of x. The capital F of x, which is nothing but CDF, cumulative distributive functions. So these are the basics of the CDF formula. That means cumulative distributive function. So now the problem, the next is the moments. This we can see later. The formula for the probability discrete random variable. A discrete random variable x has the following function x and p of x. There are given x values are 0 to 8 and p of x values are, first if x is equal to a, p of x is equal to a. If x is equal to 1, p of a is equal to 3a. X is equal to 2, p of a equal to 5a, etc. up to x is equal to 8, p of x is equal to 17. So this is the given random variable. And the question is find the value of a, p of x less than 3, p of x greater than or equal to 3, p of 0 less than x less than 3, and find the distributive function of x. So now in this, so first of all we have to, in the question it won't be given it by using the discrete random variable or continuous random variable. So from the question itself we have to identify which type of random variable. Clearly it is the discrete random variable because there are 8 x values are given from 0 to 8. So there are 9 number of outcomes. Data are only given x is equal to 0 to 8. That is total data are 9 one day. So it is a countable outcomes. So this is the discrete random variable. So the first is the question is find the value of a. So we have the formula. The first formula for the discrete random variable, summation of I equal to 1 to infinity p of xi is equal to 1. This is the probability mass function. So by using the formula to find the value of a, so summation of I equal to 1 to infinity, or we can say x is equal to 0 to infinity also we can assign. So because here the x values are given 0 to 8. So summation of x is equal to 0 to 8, p of x is equal to 1. Now p of x summation means we have to add all the data, and p of x, for example, x is equal to 0, what is p of x? A. That means p of 0 plus p of 1 plus p of 2 plus and so on p of 8, which is equal to, the formula is 1, which is equal to 1. Now p of 0, if x is equal to 0, what is p of x? Here a. If x is equal to 1, p of x is equal to 3a. X is equal to 2, p of x is equal to 5a, and so on. X is equal to 8, p of x is equal to 17a. So we have to add all the p of x, which is equal to 1. This is the formula for 1. So here the formula. Now after we added all the summation of given p of x is equal to, so it is 81a. So therefore 81 is equal to 1. Therefore a is equal to 1 by 81. The second solution, p of x less than 3. So x less than 3, we have to find the value of below 3, not included for 3, below 3. How many values are given? There are x values are 0, 1, 2. So x less than 3 is x is equal to 0 plus x is equal to 1 plus x is equal to 2. So if x is equal to 0, the given values of p of x is equal to a. X is equal to 1, the given p of x is equal to 3a. X is equal to 2, the given p of x is equal to 5a. So 5a plus 3a plus a is equal to 9a. Therefore, 9a is the answer of this p of x less than 3. We have already value of a is equal to 1 by 81. So 9 by 81 is equal to 1 by 9. And come to the third solution is p of x greater than or equal to 3. So x greater than or equal to 3. How many values are there? X greater than or equal to 3. 3 and more than 3. So here x is equal to 3 plus x is equal to 4 plus x is equal to 5 plus 6, 7 and 8. So this is the first method to solve the x greater than or equal to 3 value. 3 to 8, or we can have the another formula x greater than or equal to 3. It's a simple very shortcut formula 1 minus p of x less than 3, because this is also one of the shortcut formula for x greater than or equal to 3. So 1 minus x less than 3, already in the second solution we got the answer, it is 1 by 9. So 1 minus 1 by 9 is equal to 8 by 9. Now in the last fourth solution is p of x 0 less than x less than 3. So in between 0 and 3, x less than 3, x 0 less than x less than 3 means in between 0 and 3, how many data are given? Only two data are x is equal to 1 and x is equal to 2. For x is equal to 1, what is p of x? 3a. For x is equal to 2, what is p of x? 5a. So 3a plus 5a is equal to 8a. We have the value of a is equal to, first solution it is 1 by 81. So 8 by 81 is the answer of this fourth solution. And the fifth question is find the distributive function of x. So the distributive function is nothing but the first, already we have the formula for the discrete random variable distributive function is p of x less than or equal to x, which is equal to sigma I equal to 1 to x p of x. We have to summation, we have to sum all the given p of x, which that is the formula, and in the table itself we can fill the values of p of x. For example, here x is given already 0 to 8. So this is x is equal to 0 to 8 given data, and also the given data for p of x is equal to a to 17a. So a to 17a, first x is equal to 0, p of x is equal to a, but a value already we got it, a value is equal to 1 by 81. So this is 1 by 81, and the next for x is equal to 1, p of x is equal to 3a. So 3 by 81. And what about the third one? 5 by 81, 7 by 81, 9 by 81, 11 by 81, 13 by 81, 15 by 81 and 17 by 81. Now capital F of x, because the question is find the distributive function, means cumulative distributive function. So the cumulative distributive function capital F of x is equal to, so I give you one very easy method finding the cumulative distributive function. First data, what is the first data for p of x? So 1 by 81. So simply we can write the same value for this. And the next value, second value, by added the two values, first two values of p of x, means 1 by 81 plus 3 by 81 is equal to 4 by 81. This is the answer. And the third value of this CDF capital F of x is equal to, by adding first three value of p of x. What is this? 1 plus 3, 4, 4 plus 5 is equal to 9 by 81. Or we have some other shortcut method. This 9 by 81 simply by adding this 4 plus 5. This is also very easy. 4 plus 5 is equal to 9 by 81, and also this value we can write by adding this 1 plus 3 is equal to 4. This is also one of the cross check, one of the easy method for writing the capital F of x CDF. And how to get this capital F of x? By adding the first 4, 1 plus 3, 4 plus 5, 9 plus 16, 7 equal to 16. And one of the shortcut method, as I told you already, the 9 plus 7 is equal to 16. So this is also very easy method. Next, by adding the first 5, or 9 plus 7 is equal to 16. 16 plus 9 equal to 25. 25 plus 11 is equal to 36. 36 plus 13 equal to 49. 49 plus 15 equal to 64. 64 plus 17 is equal to 81. Anyway, 81 by 81 is equal to, we have 1. It has to be compulsory. The last answer should be 1. Otherwise, then only our answer capital F of x, which means CDF, distributive function, is exactly correct. So we are also getting the answer is 1. So our CDF is correct. That's all the given question. So in this question, so in this first discrete random variable, first of all, we have seen what is the random variable, and next there are two types of random variable: discrete random variable and a continuous random variable. We had already the formula for discrete random variable is, there are 4 formulas, and probability mass function formula, mean, variance, and a CDF formula. So these are the basic formula for the discrete random variable. And next is the properties of expectation, and properties of variance, and properties of cumulative distributive function. So after the property, directly we went to problem. Here this is the problem for the discrete random variable. So in this discrete random variable, we got all the above 5 submissions, 5 answers. Thank you all.